My name is Cieliebak, and as Martin already said, I'm a lecturer here, and I'm also running a company which does text analytics, so I do both research and producing products in that area, and I'm organizer also of a sister of this conference, the Swiss Text Conference, which we ran this year for the first time, only on text analytics with 180 people, so probably the same size here. I came to sentiment analysis about 10 years ago when I was at NetBees, a small company here in Switzerland for social media monitoring. And we were looking for good tools for sentiment analysis because this was for social media. We wanted to find out on Twitter what is there, what are people saying. It was a large issue and we didn't find a good solution to buy it. So we built something on our own using Gate at that time. And well, it did something, but I wouldn't claim it was good. So it was just a tool that had some arbitrary average quality, I would say. And then I came 3 years ago to ZHW and decided that this will be my research topic. So I work on sentiment analysis. Now I'm expanding a little bit in the direction of text analysis, but basically this is my main focus. So what is it? We want to define or decide for a given text, is it positive or negative? So not so difficult. This is a nice conference, definitely a positive text. There are other examples where you have longer texts or we have shorter texts or are more interested in, say, more restricted aspects. And we have different flavors. So basically we want to decide whether the text is positive or negative, or if it is neutral. Neutral meaning it is 27 degrees. There is no sentiment in that. Although you might think, well, 27 degrees is something positive, but other people say it's negative because it's too hot. So this is basically a neutral statement. We also have statements which are mixed. I like the car, but I don't like the color. This has two sentiment statements in it. And on the other hand, the type of text that we want to analyze is either a sentence or complete text, like a book review or a hotel review on the internet, or we can go a little bit more down and say we want to know for a particular aspect, like the sound of a car. What is the sentiment of the sound of the car in a complete review of cars? So we can have either large text, single sentences, or single aspects. And very recently, a new question came up in the realm of social media monitoring, that is quantification. You're not interested in a single text, but for a collection of texts, what is the ratio between positive and negative texts? So obviously you can do sentiment for each text and then compute the ratio. This is trivial, but people are looking for more smarter ways to find this ratio by combining texts or doing subsets of text. So basically this is a set. Now 3 years ago, oh sorry, let me do some examples. Can you read it from behind? Okay, so these are true trees that we try to classify. And I suggest you read it and try to find out what the sentiment is. So, quick poll. The first one, who thinks it's positive? Negative? Okay. Yes. Next, second one is negative as well. Sorry, it was too fast. That one, positive. 7, 8, 9, negative. 1, 2, 3, 4, 5. Okay, not so trivial. The annotators that did it in English said this is positive. Last one. Who thinks it's positive? 1. Who thinks it's negative? Who doesn't have a clue what it is about? Honestly, I don't know what it is. Maybe it's negative because of the last statement, but I really don't know. I don't understand it. So it's not so trivial. If I give you something like 100 sentences, I would expect that we don't agree on one single sentence. And this is, we do this in our courses at some time. I give 20 sentences to 20 people, and there is no agreement, no total agreement. So we cannot expect to have something like perfection on the data. The human annotator agreement is something like 80% if you have good annotators, something like 40% if you have annotators that look at it and say, oh, this is positive, this is negative, this is positive, and they go on. So it's like in the slide that we saw already, there is some agreement and you can extract the information if you have many annotators, but if you take only one or two, you cannot expect that they agree, and you have very dirty data, so to say. So, and if human cannot do it properly, then machines cannot do it better, so we can expect something like an upper level of, say, 80%. F1 score. Okay. Now, 3 years ago, I talked to a CEO of a sentiment analysis company, of a social media monitoring company actually, and he said this. Which company? Yes, I know this question will come, and on purpose it's not that. It's a huge player in the US. They are specifically doing text analytics, and we did an evaluation how good are current sentiment analysis tools. This is 2013, and you want to take a picture? Sure. Okay, so what we did was, we are a research institution, so we said we can do it very neutral, very objective. So we took 7 text corpora from the net that were publicly available, in total 28,000 texts with tweets, news, reviews, and various types of texts. Then we took 9 commercial tools and we asked them for free access, and the only restriction was it can do English text, it can do sentence level sentiment, and they gave it for free because someone said you have to pay 20,000 francs, and we said okay, nice, we don't do this. And so this is the result. What you see here are 2 lines. The blue line is one particular tool, which was the best tool that we found, and the green line is for each type of text. So this is reviews, headlines, reviews, news, quotations, and tweets. The best tool that we found among the 9 tools that we evaluated. And this is why the guy said they all suck, and we too, because it was something like below 60% F1 score. So F1 score is the standard measurement for determining the quality of sentiment analysis tools. Which means if you take 10 documents, 4 out of them are wrong. Okay, so if you build a tool and you show the user 10 documents and 4 are wrong, he will probably say, come on, this is bullshit. So this was 3 years ago, and I want to tell you now what happened in the last 3 years and where we are now and what is state of the art. Oh, by the way, this is the line of, for each corpus, the worst tool. We have 3 classes, so doing a random choice would be something like 33%. Okay? So here is, okay. Yeah, you can still buy these tools, by the way, if you want. Okay. Now, at the same year, an evaluation started, a competition, which was called Cieliebak, semantic, how is it called? Workshop for semantic evaluation, I think. Oh, okay. So this is a huge workshop, a huge conference basically, which runs several tasks, and one of the tasks is sentiment analysis in 2013, and it has several subtasks, and I'm looking now at the task sentence level on tweets in English. So, basically you are given a couple of thousand documents to train your system on, and then you get not annotated tweets, and you have to classify them, and they evaluate the quality of your system. And this is the scores of the last 4 years. So 2013, first round of the competition, we were at 69%, and this was feature-based, so people engineered text features like n-grams that was mentioned already before. How long is the text? How many exclamation marks are at the end? What kind of words are used? Are there hashtags or not? And this was all hand-engineered and built into And then they used a large set of dictionaries, basically 5 dictionaries with something like 100,000 words in it, which were sentiment dictionaries. So for the words in the dictionary, there was always a score whether the word might be positive or negative. And the winning team, NRC Canada, was the first one that really used a huge amount of large dictionaries. And they won because of that. Then in the next year, everybody did the same. The score slightly improved because the dictionary became larger and people did some smart feature engineering. And we had the first 2 participants with deep learning. But they were on 2nd and 5th place as far as I remember. And then the next year, with Webis, the score dropped. Okay. And the solution was, they used 4 different approaches of feature engineering, put it together, set a meta classifier on top, and showed that this is basically the best system that ran this year. And now, in 2016, we had a solution which used deep learning. Who doesn't know what deep learning is or has never heard of deep learning? Nice. Okay. So this is the first winning team with deep learning with 63%. Okay, these data is not very convincing, is it? So what happened? Basically, every year, Semival generated new test sets. So they hand-annotated test sets, and they became, over time, more sophisticated, more difficult to classify. So it's not that the tool became worse, but the tool became probably better, but the test data became more difficult. One lesson to learn, it depends on the test data what the quality of the tool is. You cannot say sentiment can be solved with 72%, because in your domain, in your test data, it might be something like 63 only. Okay, now let's look back. These are the 4 years and the respective winning teams, and this would have been the performance of the winning team of 2016. So indeed, the tools improved. So what we did was, basically we were winners, so we could do this. We took the tool and trained it only on 2013 data, and it was better than the winner that year. Then we took only the data of 2014, trained it, and we were better. So basically, the technology with deep learning has improved. Now this was half a year ago. We have been quite successful in improving the system, so we are now 1% above all these values. So we could even improve it slightly more, but still we are about, well, in good data, 75%. If the data is not so good, it's something like 63% still. So it depends on the data. Okay, now let me go a little bit into the technology that is behind. If you want to know more about it, there was a talk yesterday at the Deep Learning Day here in the conference, where one of the authors of the system, Maurice Gonzenbach, gave an introduction in the technology. So if you want to dive deep, there was a videotape of that, you can look at that. What is it? So what we use is 3-phase distance supervision. And let me walk you through this chart in 2 minutes. So we start with Twitter data, and there are 2 phrases in the training step. One is we take a huge set of raw tweets. That is, we just crawl tweets from Twitter. Here we use 200 million. And then we use standard technologies for word embeddings, like word2vec or GloVe, and compute word embeddings. Word embeddings is basically a dictionary, and for each word you have a vector that represents the semantic of the word. And it is generated automatically from the context in the text, how the word is used. It has been developed partially by Google. This is word2vec in Stanford, and it's a very good way to represent words, the meaning of words, even if you don't have any human interaction with the texts. So what you get is this huge matrix where each word has an entry of, in our case, 50 dimensions, and it's a set of numbers. And these numbers represent how the words connect to each other, what the meaning of the word is. Okay? Now this is totally unsupervised, so you just take the raw tweets and it automatically generates these word embeddings. Then we did the distant phase, which means we searched for tweets that contain smileys, positive and negative smileys. That gave us 90 million approximately, say 45 million positive, 45 million negative smileys. And then we used distant supervision to adapt these word embeddings slightly. And now I see that I didn't change the values. They should have been changed. You probably saw it already. So now we have adapted word embeddings, and what happens is that the word embeddings try to, or represent now a little bit what is the sentiment of the words also. Before it was only the meaning, in which context were they used, but now since we have these smileys, and categorized by smileys, they are a little bit modified to represent also the sentiment of each single word. And now in the third step, we take annotated tweets. These came from Semival, 18,000, and we use this two-layer CNN to, and these word embeddings to build a predictive model. And now for a new tweet, an unknown tweet, we can classify it as positive, negative, and neutral. Okay? I have to look at the time. So, what happens? This is the architecture of the CNN. Basically what we do is we take a huge set of convolutions, and we have two-layer CNN, who knows it, of one convolution, one max pooling, another convolution, max pooling, and then softmax to output the result. So basically this is the architecture, and these are the parameters that we learn, and in parallel, while we are doing the since we have the annotated tweets, we not only update the parameters of the two-layer CNN, but we also update the word embedding slightly whenever we see that a tweet is positive or negative. So what happens with the word embeddings? We saw that this distance supervised phase helps a lot. So if you group words by their word embeddings, you have something like this. You have words that are used in very similar contexts, like well, bad, glad, good, worst. They are grouped together. They are very similar vectors. And on the other hand, you have something like fantastic, wonderful. Here's, I don't know, glamorous, damning, gorgeous. And after the distant phase, these words have moved a little bit. Because before, we had well and bad very close together, and now we have a cluster here of positive words, and then bad, cry, worse, horrible is somewhere different position. So this distant phase, although it was slightly unsupervised, we only had these smiley tweets, helped to separate the negative and the positive words. And this helps in the sentiment classification at the end. Another approach would be to generate a lexicon by hand with positive and negative words. But this you have to do for every language, and you don't want to do this for, say, 500 languages if you want to do that there. Okay, now typical chart for machine learning. The more data, the better. So we saw on one hand, for the distant phase, we increased it up to 200 million tweets, the smiley tweets, and you see that the lines are still increasing, so we can expect that if you have more smiley tweets, it will improve slightly more. On the other hand, the number of annotated tweets with 18,000 is apparently at the end, at the upper limit already, or has reached the boundary. I would say something like 5,000 to 6,000 tweets is something that you really need, but whether you have 18,000 or 20,000 doesn't matter so much. It will only improve slightly. Sorry. No, this is a large table and it has so many information that I have to move Martin out to give you all the details you can find. But I will try to fix on the most important. So what we did here is we trained the system on 4 different data sets. This is training data, and then we evaluated it on these data sets as well. So you can expect in the main diagonal that the system is trained on tweets and evaluated tweets, so it's good. This is trained and evaluated on movie reviews and so on. So the diagonal basically is train on a domain, and test on a domain. And what you see in each line is that this is basically the best to do. So if you train on tweets, it's not as good as if you train on reviews if you want to do reviews. So train on the domain where you want to do something. But the last line, this here, is we train on all the training data. So we take the union of these 4 sets and we train on it. And what you see is that on each test set, it's approximately, not exactly, but it's close to the best system on the domain. Which means if you have a huge set of domains that you're interested in, you can throw everything together and build one system. It's not as perfect as one domain, but it's close. It's the best you can do, maybe. Even if you don't know the domain that you want to do. So take as many tweets as you can and train it, and then you can hope for a good result in a different domain. How about other languages? It's very similar. As long as you have enough training data, you can achieve good results. So for Dutch, there is very little training. I started at the top. So German, we have 10,000 tweets, 64%. Spanish, we have a huge set of tweets, 71%. This is measured in precision, and in other languages it's very similar. This is special because they were only labeled with positive, negative, so it's not neutral in the tweets. This is why this is so high. So if anybody sees a system where they claim we have something like 96%, it's probably that they only can distinguish positive and negative if it is a sentiment tweet, but they cannot detect the neutral ones. Okay, so this is it. Here is over. Now let's see some applications. First of all, you can buy all this stuff. There are these huge players like Google, IBM, Microsoft, SAP. They all have a solution for text analytics, and they all have a solution in there for sentiment analysis. Then there's some NLP specialists that are concentrating on this stuff. I wouldn't claim they are better or worse, but they are probably more flexible in adapting their solutions to your needs if you want to have something. And then if you want to build on your own, there are 2 standard toolkits usually used. In Python it's the NLTK, and in Java it's the Stanford NLP as basis for all this stuff. And then you find a lot of implementations for sentiment analysis as well. Okay, oops. So, applications, 5 minutes, nice. Applications. Assume you are running a website for hotel reviews. Well, you can ask, is a review positive or negative? But you can also ask in more detail which aspects of my hotel are positive or negative. So this is aspect-based sentiment analysis. Pretty hot topic, I would say, because nobody can do it very good at the moment. Research topic. But the goal is that you have something like food, drink, room, staff, facilities, and so on. And for each of these aspects, you find the proper sentiment from the text. So you are given large text, and you write in the text, well, I came to the hotel, the reception was very nice, but the room was dirty, and then I took a shower and it got cold, but the position was very nice because it was close to the beach. And now you have to extract all these single aspects and classify the sentiment, positive, negative, and put it into charge. And you can do it for arbitrary products, of course. As I said, not really well solved yet, because this topic modeling, what is the cleanness of the room, what is the reception, this already is a difficult task. So you have to solve 2 tasks, detect this topic, and then detect the sentiment, which multiplies in a way the error. Second application. This is a paper from 2015. They tried to predict how many people will die from a heart disease, heart attack, in the US in various counties. So US has something like 1,300 counties, districts, and they took from the CDC, that's the Council for Clinical Data Council or something like that. They took the mortality rates for heart diseases for each county. And on the other hand, they took Twitter data from 2013 for all these counties. Twitter has geolocation data in it. And then they analyzed the mood in the tweets. So they did at first some topic modeling, and they found out that there are topics like boredom, fatigue. This was automatically generated. And then there are very positive topics. And then they correlated the mortality rate with these topics. And they found out that if there are very many uses of negative topics, then people are likely to die of heart diseases. Okay? Nice application, because now you can look at Twitter and say, here the heart attack rate will be high or low. But when I read it the first time, and I didn't come to a conclusion in the article, I thought, well, this is bullshit. Why? Because Twitter users are about 25 to 45, and they don't die of heart attacks. And the people who die of heart attacks, well, after they died, they are not writing anymore. But before, they are probably not writing on Twitter. And so what is the connection? And the conjecture, and it's really a conjecture of the authors, is if you live in a town where people are very happy and have a relaxed life and so on, well, people don't die of heart attack. So if you live in Hawaii, in comparison to Los Angeles, obviously. Huh? On the other hand, if people live in a town where everybody is relaxed, like Hawaii, they tend to write more positive tweets, even if they are 35 and they are at risk for heart attacks. And this is a connection. So if you have the community which is in a very positive mood, then you are writing in a positive mood. And this has been shown before, that different towns have different moods in general, or even different time scales. You write more positive in the morning than in the afternoon and stuff like that. And so this will be used now to predict for insurance companies what is the heart rate risk in various counties in the world. Yeah, I skipped this example because of the time. Last example, everybody thinks he's anonymous on Twitter. Yes, he is, but we can find out some data about you, like your age and your gender. So what you can do is you do a classification by age and gender, and you can predict it with 85% accuracy approximately. This is also a competition running every year, and it has improved. Okay. Now, talking short, sentiment analysis, approximately 70% has one score if you're training on good data, if you have good annotations, and you really know what to do with the most recent systems. The more data, the better. Yes, definitely. If you want to do something by your own, get your own data, annotate it, and do as much as possible. And yeah, there's a couple of important applications. I mentioned only 2 or 3. I can extend this list to 25 if I want to. So that's it. Thank you very much for your attention. And now there's time for questions.